So how would I start my first warm-up?
X equals 5.
X equals 5. And? Yeah, or x equals -5. Good. Those are both already solved. Those are our two solutions. What about the next one?
X equals
Oh, just write it out first. Let's not solve it all the way. How'd you set it up?
plus 4.
X minus 4 equals 9. X minus 4 equals -9. Yeah, don't try to solve them all at once. All right, so I add 4. X equals 13. Here I add 4. And x equals -5. And if you plug them both in, they check out. What are your questions on these warm-ups?
Is this what we doing for today? I'm going to figure that out.
Yeah, we're not doing piecewise functions anymore. All right, these are graphing absolute value equations. Like I said, they're a little harder than graphing regular linear equations, but they're not as hard as piecewise functions. They're somewhere in the middle. You guys should definitely write these in your notes. It's extremely important, especially this part right here. This is the form we're going to be working with today. You can see it has an absolute value in there. Sometimes something is subtracted from x, that's our h. Sometimes there isn't, and then h would be 0. But whatever you're subtracting from x, that's your h. Whatever you're adding outside the absolute value, that's your k. And hk is where the vertex of these graphs will be. There's also a line of symmetry. It's just the vertical line through your vertex. These graphs look like a V. This part up here, A, if that's positive, your V will open up. If A is negative, your V will open down. What are your questions? So for this one, we are just going to use a table of values. When you are in any doubt about how you should graph something, always make an XY table. So until we kind of figure out what these should look like, let's just do it this way. So when I plug in -2, for the x, I get -3 in here. Absolute value makes it +3. Times 2 is 6. Plus 2 is 8. Same sort of deal when you plug -1 in, you'll get 6.
Can we just do like 3 numbers? 1.
We don't have to put all the
No, normally in a linear equation, I would say 3 numbers is just fine. I would like you to do all of these, though. You'll see why. It's a weird-shaped graph, one that you're probably not used to. So, yes, do all of these if you're following along in your notes. When you plug 1 in, you'll end up with 2. When you plug 2 in, we'll end up with 4. When you plug 3 in, you end up with 6. When you plug 4 in, you end up with 8. So you can kind of see when we graph these, it's going to go down and then back up. It will form a V shape. You look at some of these in a couple chapters that are parabolas. It's more of a U shape. These are very rigid, though. It's a V shape. Again, I don't recommend you use a table of values every time, but until we figure out a little bit more about these things, let's just look at the table of values. So here's my graph. I'm going to graph the points that I just found.
Do we have to erase anything?
And you can see it is forming pretty much a perfect V. So I'll give you guys a second to catch up. I know I went through that kind of quickly. The table of values is just computation stuff. And then graphing. Connect it with a V. Now, we talked about, if you look at H is what they're subtracting from X. What are they subtracting from X here? 1. What are they adding at the end? 2. That's where your vertex is located. And you can see from this graph, here is our vertex. It's at the point 1, 2. We can also tell where the axis of symmetry is. It's just the vertical line through the vertex, so our graph should be symmetric about this line. Now, can anyone see why this 2 is significant? Look at the points and how they're changing. What could this 2 represent? Check out these values.
Going by 2s.
Yeah, these are changing by 2s, right? So if you look at this line to the right, it's the slope of it. And then this line is just symmetric across our axis of symmetry. So A is always your slope. It's a little different than the regular slope. You have to use the axis of symmetry when you're thinking about it. But since it's positive, we know the graph is opening up. So you go up to right 1 from your vertex. You could also go up to left 1 since it's symmetric. So in the future, we can just use these 3 pieces down here to graph these. We won't have to do a table of values every time. Again, when in doubt, write it out. Do a table of values. You can see the shape of your graph. But I would recommend doing it this way. All right, so here's the first actual example that I want to use with the H and the K and the A stuff. So first, you got to ask yourself, what are they subtracting from X? It's kind of tricky on this one, but what are they subtracting from X? H is always what they're subtracting from X. They're subtracting 1? So minus 1?
They're adding 1.
They're adding 1. So what would you subtract? Negative 1. Good. So our vertex is going to be at negative 1, 3. It's always the opposite of this one and this one. All right, so that negative is going to kind of mess people up. Just remember, it's the opposite of this. Sometimes I think about it as what would you put in for X to make this 0? That works as well. So our vertex is going to be at negative 1, 3, which means our axis of symmetry is also through that point. You don't have to draw in the axis of symmetry. I just want you to recognize that it will be symmetric about this line. Now, what's our slope? Negative 2. So from that point, we could go down 1, right 2. Other way around. Down 2, right 1. We could also go down 2, left 1 since it's symmetric. So that would give us these 2 points. And then from those points, you can do it again. So down 1, right 1 from the one on the right. I keep saying 1. Down 2, right 1 from the one on the right. Down 2, right, left 1 from the one on the left. I can't talk today. You guys know what I mean. Do what's on the board, not what I say. Any questions? Let me recap the slope because I kind of butchered it while I was talking. From our vertex, everyone gets the vertex, right? It's the opposite of this one and this one. This is your X value. This is your Y value. So we have this point right here. This is negative 2, so I know my V has to go down. And then you use it just like a regular slope. Down 2, right 1, down 2, right 1. Since it's symmetric, that also gives us the down 2, left 1, down 2, left 1. So sorry, I kind of butchered that a minute ago. Any questions on this? Yes, ma'am? All right, here's example 2. Let's see if I can talk through this one a little bit better. What are they subtracting from the X? What are they adding on the end? 4. So our vertex will be at the point 3, 4. Our axis of symmetry is the vertical line through that point. So X equals positive 3. Now, does anyone know what our slope is? 1, yes. If there's not a number in front, it's a 1. And it's positive, so that means my V will be opening up. So from this point, I can go up 1 over 1, up 1 over 1. I could also go up 1, left 1, up 1, left 1, since it is symmetric. So that's going to give us these points, and then these points. And it's a V. Any questions? So to start example 3, let's ask ourselves, what are they subtracting from X? 0. What are they adding on the end? 5. So that is my vertex. You can graph the vertex. Bless you. The axis of symmetry is the vertical line through the vertex. I'll give you a second to catch up, and then we'll discuss the slope. Anyone know what the slope is? 1. So this is kind of like the last one. From our point, we can go up 1, right 1. Since it's symmetric, you could also think of it as up 1, left 1. Forms a V. And I'm done. What are your questions? All right, number 4. What are they subtracting from x? 2. What are they adding on the end? 0. So my vertex is at the point 2, 0. This graph will also be symmetric across x equals 2. What's my slope? 5. So from this point, what am I going to do?
5 over 1.
Yeah. And really, you could go over in either direction. Since it's symmetric, we'll have a point here and here. Now, on my particular graph, going up 5 and then in each direction, 1 would take me off of it. If you can fit them all in, you can keep going, but this is actually enough for this graph. Questions? Now the fun part, the slope. So what you were going to say? She said down 1, left or right 1. Okay, good. We all agree. Down 1, and then you can either go left or right 1 since it will be symmetric. And again. And fill it in. Now, why is this going down? That worries me. Should I be worried? No. A is negative, so it should be going down. Great. What are your questions? I told you guys lots of examples. Hopefully you're thinking these are easy. We can go quick. What am I subtracting from x? 0. What am I adding on the end? -2. Good. So 0, -2. Also the place where it's symmetric. Vertical line through that point. And how am I going to do the slope?
Down 1 over 1.
Yeah, good. Just like the last one. Down 1, left 1, or down 1, right 1. Either way you want to think about it. But it is symmetric. It's opening down. Slope of -1. What are your questions? All right, here's example 7. Now we're going to basically do the problem in reverse. So ask yourself, where is the vertex? 3, 0. You go side to side first. So 3, 0. We are working with this form. I told you guys to write this down on our first slide. If you didn't, I would definitely do it now. It is nearly impossible to write an equation when you don't know the form. So I would get that down. Now, we are basically just going to replace h with 3 and k with 0. Now, A is a little trickier. I would argue that there are 2 ways to find A. I will show you both. The first one is just to count. Is A going to be positive or negative? Negative. Now figure out what number goes on top. What number goes on bottom? 2. Good. That, I think, is the easiest way to find the vertex. Any questions before I show you the other way? Yes, ma'am.
I didn't do the axis.
The axis of symmetry is always the x value. It's just the vertical line through that. So it's just x equals that.
Oh, that.
The 3 over 2 thing is the slope. So I knew it was negative because it's opening down. And then the vertical change was 3, and the horizontal change was 2.
Okay.
So 3 over 2. However, there is another way to do that. If you don't like just counting, you could do it by finding a point and plugging it in. So this is the form we're in, right? Because we don't need the +0. So you could replace the x with your x value, the y with the y value, and then solve. I think this way makes it a lot more challenging, but some students don't like the rise over run thing, so if you're one of those people, this is another alternative. Any questions? Do you need the +0? No, I actually wouldn't write this with the +0, but that's just me. I would just write y equals -3 over 2 times the absolute value of x minus 3. but it is up there, so we'll leave it. Any questions? All right, here's another one. Again, we are writing the equation. So check out the vertex first. Where is the vertex? 1, -2. Which means our axis of symmetry is also close to that point. It'll be at x equals 1. Vertical line through that point. Now here's the equation we're talking about, right? Where do I put the 1? H. Where do I put the -2? K. So now I'm here. The only value I still need is A. Yeah, up 2 over 2. What's 2 over 2? 1. And we know it's positive because it's opening up. Now, do you need the 1? No. Okay, I would definitely drop the 1. What are your questions on this? Again, if you don't like counting rise over run, you could use this point, -1, 0. Plug it in here. Solve for A. That works as well. What are your questions? Yes, ma'am. Number 9 is the last example of the day. Start with your vertex. Where's the vertex? Yep, -2, 2. We are, of course, in this form, same form we've been using all day. Now, what's going to happen with H here when I plug in -2? Yeah, it's going to be x plus 2. And then plus 2 on the end. So from here, you can either plug this point in for x and y and solve for A, or you can just count. I know it's going to be a negative number because I'm opening down, and this is 1, 2, 3, 4, 1. We can also find the axis of symmetry. It's just through that vertex, the x value of the vertex. There's our graph. What are your questions? Here's your homework. There are a few on here. I believe it starts 27, 29, 31, 33. Double check that for me. Where it says use a graphing calculator. You can play around with it if you have a graphing calculator. I don't require you to have a graphing calculator, so I won't require you to do those problems. So you can skip those, but make sure you pick up on the end when you're writing the equation and go to number 39. Odds. The section you can skip, it says, I think it starts 27, and the directions say use a graphing calculator. Yeah. Yeah, you can skip. It's 4 problems. 4 of them are odd. You can skip those and just do the rest of them. Homework check tomorrow, don't forget.